Picture this, your app just hit 10x traffic overnight and you've got some issues. Your servers are crashing, the site's down, nothing's working. Does that sound familiar? Or another scenario is you've built all this scaling infrastructure and it's crickets. Well, let me help you with those scenarios. They're both problems, but we can work through them. A lot of companies face downtime, especially during their busy season if you have a seasonal business. We have a client who has a lot of traffic during one event a year, and we have to build infrastructure for that one event. Today, I'll show you how to scale intelligently and make sure that you don't over-engineer anything. Try to help you set up for success when that 10x spike does happen. All right, here's some warning signs your infrastructure can't keep up. Performance indicators, things like page load time, responses, API responses, delays, any latency, any CPU usage or storage are running low, high storage, high CPU cycles, and complaints from your customer base. There's some hidden costs in that. They're not really that hidden. It's pretty basic. If your site doesn't work, if your app doesn't work, people aren't going to use it. So if you're a SaaS company and you have issues with performance, people will stop using your app. They will find a competitor. Guess what? There's a competitor. That client I told you about, we had 2 years in a row where we had issues. We met as a team before this event were to take place. Me and my team, we proposed some changes. There was another contractor on board with the client, and the client listened to that contractor. The contractor said, everything's gonna be fine. It was not fine. It was down for 2 days, their busiest time of the season, their most important event, and no one could access the website. The following year, we also proposed some changes. Our changes were shot down. Once again, the site didn't work. But we cannot make decisions for our clients. We can only advise them. We can strongly dissuade them from going with low success option, but at the end of the day, it's their decision. Now, the last couple of years, that site has worked very well because we implemented our approach. If you need help with that, want to book a call with me, 15 minutes, I could help you kind of brainstorm and try to come up with some ideas on how we can help, how we can work together. And my goal is to provide value in that 15 minutes for you. Not a sales call, let's just talk tech. Okay, so there's several fundamental things you need to learn about scaling before you can scale. You need a good foundation that's scalable. You don't want to have, back in the day, early 2000s, we had on-premises server rooms, if you remember that. If you don't, we did. There were also some things that ran on Frank's laptop under his desk, and I don't use that. It's not a joke, actually. That is something that I've seen. A desktop you don't touch, or a laptop you don't touch. You just make sure it's on. If the power goes out, you got to reboot it. You got to turn it back on. That was business critical stuff running on some guy's workstation. But now we have the cloud. We have a lot of different options. One way to do this is to go serverless. So you don't have provision any servers. You can use like Lambda in AWS or Azure Functions, and that will be code that's executable and available via an API call, and it's always up, always running, auto scales. Bob's your uncle. You don't need to worry about any of the scaling stuff if you use that. It does take some re-architecting. So if it's custom software, you have this full control of the source code, that could be an option for you. Another thing is microservices and stateless, and then database optimization and caching strategies. Caching can be done in the database level or the service level, the application level. So we can cache various different places. U.S. states I haven't changed in quite a while. We probably don't need to do a fresh refresh from the database every time we get the state list. We can probably cache that. There are two approaches to scaling, and that is vertical scaling. So you scale up, you may add more power to existing servers, add more RAM, add more CPU, add more hard drive storage, and then the other one is scaling out. You distribute the load amongst many servers versus one server. Another note back to that client, one of the issues we were running into is their public website hosted a lot of static content. So we moved that to a CDN. That took all the processing for static files, images, videos, PDFs, into the CDN, and we didn't have to worry about it on our end. That is a horizontal scaling piece because we offload it to something else. Okay, we have 3 different options with smart technology choices. We have managed services versus self-hosted solutions. Managed services, let's talk about database. Let's say we're using MySQL. We can have a MySQL instance on a virtual machine running in the cloud. That's our instance, it's our server, we manage it, and that is a self-hosted solution. Managed services, we can sign up for MySQL hosting, and AWS or Azure manages that. We don't manage it, we have full access to it, but they run the server. We can just choose what size server we need, and it's good to go. Another thing is auto-scaling and load balancers. Auto-scaling is that horizontal where you can add more servers if it gets busy. Amazon is great at this because that's their core business, since they're an e-commerce store. So every November, December, they're busy and they're used to being able to auto scale. They add servers and they contract and reduce the amount of servers. And load balancer, think of it as, like a central thing where traffic comes in and it picks the right server to go to. So it'll go here and then there and then there. And there are more smarts into it than that. If one server is doing a lot of work, it will go to a different server. And I mentioned CDN, that's a content delivery network. That's a way to offload any processing for delivering static files to your end user. That's a great way to minimize your compute and to improve performance without much work. Okay, so how do we scale? I have a scaling metrics. There's a link in the description. You can take a look at that. We need to choose how to figure out if we want to do horizontal or vertical scaling, the cost implications of each approach. Sometimes that's a little tricky to figure out because you're measuring kind of unknowns. If you have 5 extra small servers versus 1 extra large server, what's the cost of that? And is 5 small servers or extra small servers, is that equivalent in workload to the big server? That's a way to take a look at that, try to see what makes sense, and if you can kind of glean some information on what size you need. You have timeline and complexity considerations. Using the cloud, if you want to go all in on cloud, I'd go serverless. That requires a little bit more forethought, but it does eliminate your need for scaling, but you are locked into that vendor. So if you want to move from AWS to Azure or Azure to AWS, those two are not exactly the same. You'd have to make sure that your code will work in the new service provider. Okay, so what are some implementation steps? First of all, set up a load balancer and traffic distribution. I know that just sounds so boring, but it saves you headaches down the road. You can do database scaling, partitioning. You can scale the database pretty easily. That's usually not where the problem lies. The problem is usually in the application itself. Databases are pretty quick. You might run into some issues if you don't have proper indexes set up, or if you have long-running queries. A lot of times when you have database issues, it's not the hosting itself, but it's the database schema that's causing the issues. We have caching layers. You can cache at numerous places along the way, and caching is your friend. You want to make sure that when the user is getting cached data, that's okay, because cached data is stale data. We don't want it to be stale unless, if something's changed, we want to invalidate the cache and then provide them a fresh copy of the data. Another thing to consider is a monolithic service implementation. How do we break that up into microservices? Microservices are great, but they also have a downside too. If you need customer data, but then you also need address data, is your microservice just going to get customer data and then you have to make another call to get address data, or do you want to combine those? Then are you creating a monolith and a microservices architecture? Those are the things you need to figure out. There's no one size fits all. It's a lot of trial and error and going back to your experience and seeing what makes the most sense for this situation. Also, we need monitoring and metrics. We need to know what's going on, where the performance is lacking, how we need to improve things, and we need to make sure that we have a good infrastructure in place that will support the client base that we have. One of those steps is data forecasting. What size database do we need? If our database grows a gigabyte a day, well, why? First of all, and then if it is growing that way and that's legitimate, how do we forecast when we need to upgrade our our data storage. And how do we manage that down the road? Maybe we need to use like an AWS S3 or an Azure blob storage for this type of data instead of storing it in the database. That's an architectural change. We'd have to be mindful of the repercussions of doing that. That's typically not a super quick fix, but it is like a medium-sized fix. Okay, here are some scaling pitfalls. The two things that go hand in hand: premature optimization and over-engineering. Over-engineering, I've seen this movie. I know how it ends. Some super smart engineers get in problem-solving mode and they solve problems that don't exist. Have you seen that before? I've seen that movie a ton of times. One example I've used is if we have a quarterly report, it takes 2 to 3 minutes to run. Why are we optimizing it? It's a max, 3 times 4 is 12 minutes a year. We don't need to spend 2 months fixing something that costs 12 minutes a year. That's a huge waste of resources. Let's take those big brains and let's put them on real problems. So first you need to know what problems to solve, and then you put those big brains on those problems. Premature optimization is also the same thing. We don't need to optimize something that's not broken. If load times are adequate for our app, don't optimize it. If there's one piece that starts getting slow, take a look at it, see how we can fix that. Another thing is security. So security should be at the forefront of everyone's mind. When building systems, building infrastructure, security is important. You need to find that balance between convenience and security. 100% secure means you have a computer that has no network access. That's the only way to have it 100% secure. 0% secure is you have no security involved at all. No usernames, no passwords. You can just launch it and run. Not a good idea either. So how do we find that balance? You gotta find that balance between security and convenience. Make it inconvenient enough so that people who are supposed to be on the system kind of complain a little bit. We want people to complain, like multi-factor authentication. I hate it until someone tries to access AWS on my behalf and is impersonating me, tries to hack in and launch a bunch of servers and do a bunch of malicious things with it. So I do like multi-factor authentication. I just also don't like it because it's inconvenient. So that's kind of the perfect place where it's a little bit inconvenient for normal users and it's near impossible for bad actors. Another thing, don't just go in and start creating a bunch of stuff and not monitor the costs. Costs are a big issue. The cloud is not cheaper. The cloud provides more benefits than it does negatives. That's why we use the cloud, is that we can have an enterprise level infrastructure at a small business price. Okay, so here's a little action plan for you. We've got this week, the next 30 days, and the next 6 months. So this week, 3 things. Audit your current performance and capacity. Take a snapshot, see what's going on, what's going well, what's not going well. Number 2, set up basic monitoring and alerts. Your infrastructure guy should know this. If you don't have an infrastructure guy, hop on a call with me. I know a guy. I know lots of guys, actually. Lots of good infrastructure people out there. We can help you get up and running. Number 3, identify your bottlenecks. See if there are any performance issues, where those are occurring, what level in your application it's occurring at. And just right now, we're just trying to assess, trying to take a snapshot, trying to take a look at things and see where they are. Okay, the next 30 days, also 3 things. 1, choose your scaling strategy using a decision framework. I have a little tool you can use. Me and Claude, we work well together. So we built this little tool for you. Number 2, plan your infrastructure improvements, if applicable, right? If everything's going well, you don't need to improve anything. If things are not going the way you want, then it might be time for improvement. Or if you see something that could come up down the road. If you have that one event every year that's coming up and you're worried that it's not going to be a success, plan now. Number 3, scaling triggers and thresholds. So typical rule of thumb with CPU, if it gets over 80%, we want to kind of throw more resources at it to reduce that so it's below 80% at all times. Okay, so the third section, long-term strategy over the next 6 months. Number 1, build scaling into the development process. If you're writing custom software, scalability should be at the forefront. If you're a SaaS company, you should know, what does that look like? How do I need to scale? Or do I have peak times of the day? Do I have downtime? Do I have are things that look for patterns and adjust according to those patterns. Number 2, create incident response playbooks. So what happens if something goes down? How do we manage that? If something goes down, it's too late to scale. I mean, you can scale and then it'll kind of get back up, but you need to scale before it goes down. You scale before you have that big push. And number 3, plan for team growth and skills development. In the tech world, we are always learning, always learning. There's not a time when I haven't been learning. Your team should always be learning. Okay, so scaling, key takeaway I want you to take from this video, if you've made it this far, congratulations. Scaling is about preparation, not about reaction. We should look ahead for scaling opportunities, not react to a bad situation. I've got a tool in the description you can link to. Take a look at that. Tell me what you think. It'll help you come up with a scaling strategy. Also, share your horror stories. I love a good horror story. Stephen King is not my personal pen pal, so I can't get horror stories directly from him, but I'd love to hear yours. Leave a comment. Let me know what you think. Book a call with me. I'd love to help you out. And as always, like the video, share, and subscribe, and I'll catch you again next time.